All right, well, everyone, thank you very much for joining us in this session of optimizing Kubernetes, particularly not just optimizing it for cost efficiency, but for reliability, which is one of the key pieces that we want to talk about through this session. Joining me, myself, I am Kent Hua. I am a global solution manager focused on GKE and app modernization for optimization. And joining me is Chris Muir from Priceline, as well as Thomas Evans from Kubecost. So they will come on and talk about some of their pieces, and we'll kind of run through that. We will take some questions at the end and possibly some post-session as well if you have any questions afterwards. So I will get right to it. From a topic perspective, I mentioned the presenters, Chris and both Thomas, but I'll cover the research. So for those of us that may or may not be familiar, some of us may have caught it late June from a Google perspective, we released a report to kind of focus on optimization of Kubernetes in the context of cost efficiency as well as reliability. And one of the key pieces when we talk about the report is focusing on cloud agnostic. So albeit here I'm speaking from a Google Cloud perspective, the report itself is cloud agnostic. So albeit from this perspective, as I mentioned, I will cover some Google Kubernetes Engine aspects as well. So with that in mind is, as part of the report, we went through a methodology of how do we classify? For those of us that may have been familiar with the State of DevOps report in the previous years, they had some level of classification of how they segmented some of their participants. In this case, our participants were anonymized GKE clusters. And this fleet was less than or equal to 3 nodes. We didn't want the smaller ones. We wanted some of the larger ones as well to kind of mix and match the overall construct of how we segmented. We used the construct of classification tree to help us segment this, as well as give us some little semblance of opinionation, which you'll notice on the bottom right-hand corner is the at-risk section. And that's when we talk about that reliability element of it, is where does that play into all of this? We did a quasi-interval. As I mentioned earlier, we have segments of elite, high, medium, low, as well as the at-risk portion. And funny enough, so we actually took this data grouping for January 2023. One would think that, oh, we actually first took this of November 2022. And for those of us in certain sectors, November of 2022 is very critical to our business. And we kind of used that as a measuring. So looking through it, we noticed that the data didn't actually change very much overall. The story kind of told itself equally overall. So we chose January 2023 as the data set. And we kind of walked through that. If we look at the report as a whole, some of us may have caught the blog post. One of the key things outside of the report that we're talking about is to have a minimum set of reliability for workloads that require it. Not all workloads require a sense of reliability, but if workloads do have that minimum sense of reliability, the least thing we can do out of this entire session, at least for my part, is set resource requests on your workloads. So for those of us familiar with Kubernetes, we know this is a construct that we can use in order to reserve certain resources within a node of a cluster. The reason why we want to set resource requests, albeit reserving, is that it has a lot of critical things that it controls or augments within our cluster. When we think about setting resource requests, we think about, I'm just reserving resources. But in reality, we can see here a list of different things that can be augmented, tweaked, impacted as a result of not setting requests on our workloads. So that's a very critical thing. We think about if we're looking at auto-scaling for our nodes, because that's how Kubernetes usually triggers it. I schedule more pods, they're in pending mode. If my cluster autoscaler is enabled and I have more resources available to me, it will scale up. But if I don't set requests, it will just keep throwing it on similar nodes without understanding, because that's how Kubernetes schedules, by using requests. And this is sort of that critical element. If we look at it from this particular use case, I said throw a bunch of pods in a particular node. This would actually potentially scale up if I hit my 110 pod limit, if that's my maximum pods per node, if I set that up. So that is one mechanism I can use to help me drive that behavior. But all I have to do really is set requests. And we'll talk about that a little further as well. As part of the report, I mentioned some opinionation. A lot of that opinionation is driven across what we've discussed with customers like yourselves, as well as organizations to say, what is important? Because we know Kubernetes can emit a lot of metrics, but how do we get some semblance of understanding? And these are what we see as the golden signals. From left to right is workload right-sizing. Am I asking for enough of what I'm actually needing within my workload? Am I using too little? Am I using too much? How do I right-size that? How about if at non-peak, depending on the industries that we represent or work through, we have different off-peak times. And if there are off-peak times, we'd like to scale down to reduce our consumption of resources because there's no demand. So how do we set that and how do we measure that? The next piece is a lot of what we see in this room. We talk about cluster bin packing. This room is fairly bin packed. And what happened was, essentially, we can't vertically scale this room anymore. So we scaled horizontally. We have a session on Thursday. So that's another way of viewing it from a bin packing perspective. We're fairly packed in this room right now. And how do we measure that? Because I want to make the use of the machines that I provision. The last piece is how I adopt cloud discounts. And cloud discounts come in the form of spot type of VMs or discounts that are available. In this case, for Google Cloud, committed use discounts that I can apply. And this is something where Chris will actually come on and tell how Priceline did it from their perspective, because I have multiple strategies that I can apply when I talk through discounting and go through that. But these are the signals that we're measuring. We added one more metric, which was essentially which workloads are not sending requests in how we segmented our clusters. So as a result, if you hadn't had a chance to catch the report, there are 7 findings that we kind of alluded to or ran through. And the first piece is setting requests. By understanding setting the amount of resource requests for the workloads that have a minimum reliability. Notice that I said minimum reliability because there are some workloads that qualify that I want to be best effort. But there are also some impacts if they are best effort. So that's the most critical thing. As I mentioned, that was that third slide that I had in the presentation. The second piece, I showed 4 signals across. Workload right-sizing, downscale, bin packing, discounts. Workload right-sizing is actually the most critical one. Because if you think about it, if my workloads are not right-sized properly, I can impact how I scale potentially, how I bin pack, because I might not pick the right machine. Because Kubernetes is going to say, what machines do I need? And if my applications say I need a lot more than I actually need from an application perspective, I may look like I'm bin packing very well, but in reality, I may not be bin packing as well as I'd want. And the third one is essentially being able to, if I overexert an index on cost efficiency, I can impact my reliability. For instance, I start bringing down certain resources, I can impact the reliability of my workloads because I'm getting too aggressive in how I tear down particular pods or tear down particular nodes. The fourth one is, I just spoke to you about pods and nodes and all this technical stuff from a Kubernetes perspective, but when we are performing these actions within our clusters, there is real life potential end user experience that may be impacted as a result. Because we think about it, workloads are coming through. If I need to scale up, it takes time before I can actually serve a request that comes through. If I'm bringing down a workload, what about that transaction that's in flight? So those are things that can impact my end user experience. So that's the fourth key finding. When we look at the fifth one, is all about, yes, I mentioned demand-based downscaling is a metric, but how about the impact of it? We want it to be automated. We don't want to be involved as part of this downscaling mechanism. So we need to use constructs that are available to us within Kubernetes. Horizontal pod autoscaler, which helps us go wider, is one mechanism to elastically grow as well as shrink without us being involved. Otherwise, we, on the operations side, developer side, have to determine what are my max, my minimums, and I'm going out through my pipeline to adjust these sizes. That may not be the most quickest reaction. We want to let the cluster perform for us if our workloads allow us to do such. The sixth one is about elite and high performance. They do take advantage of cloud discounts. And what we usually see when we talk about these clusters and the segments, usually the clusters that are larger, we pay a lot of attention to these clusters. And we have more visibility, as again, Chris will kind of run through. Being aware of what our workloads require gives us a more sense of confidence when we want to say, I can commit to these certain amount of resources from a 1 year to 3 year perspective, depending on our level of confidence. The last one, it depends on the tooling we use. Because a lot of tools that are out there very much focus on allocation of cost is based on or equal to the requests that I set. So on that third slide, when I said set requests, if I'm not setting requests, potentially those costs are not accounted for. And that's something that we need to addressed. Kubecost does it a little differently. They take max use or requests. So that's one way to look at it as well. But we just need to be cognizant if we're using third-party tools or other tools, what is being factored in as far as what is an actual request. It's very interesting we see. I can read numbers, but in reality, when we look at it, for elite and performers over low performers, they get more value, they get more for what they pay for. And they heavily utilize discounts because they're aware of what's happening. When I context or construct when I said they, these are clusters. We don't have any groupings of these segments or anything. These are just clusters that seem to exhibit these behaviors. But in reality, when we look at it, they are getting more use of what they have, which typically means that utilization is probably higher, right sizing is a little bit better, or better awareness of the right sizing. And if my right sizing is just right, because there is no magic to it, I just don't apply a number. I need to understand these on a per workload basis, that I can then confidently determine what should my discounts be as a result of that. Going back to this last segment that I said we carved out for, not only is it that if my cost allocation's impacted, the reliability could be impacted, is that negative user experience that could potentially happen. Because we think about it, is when a node gets to its limit, if it's a best effort workload, which is a workload that does not set requests, it's unfortunately the first to go when the kubelet needs to protect itself. So it has a starvation mechanism that says, I have no more resources, who's the first to go? Best effort. Then burstable, guaranteed is that one that I reserve resources, but things can still happen. But we can see a tier of how the kubelet reacts as a result of this. And we see this a lot. For instance, some of our workloads exhibit that 1.6x times more. So this is something from a best ever perspective, what is that impact to my workload? And the last one we talk about is best effort is setting requests, but what about the burstable ones? So this is under-provisioned memory. Memory is something that with CPU I can throttle, albeit can impact user experience. Memory is fairly static. Once that memory is consumed or allocated for, I can't really reallocate it unless that pod goes down. So that's something that can impact our end user experience as a result of that. The at-risk segment also has some sense of, I want to optimize. So potentially, when we look at the at-risk segment, could potentially be over-indexing on that low-hanging fruit we think of cloud discounts. Because I can think about it from the perspective of, I want to save money. I should just commit to a certain amount of resources, which could be helpful. But remember, that is the last part. If I resize and actually properly workload right size, I may now be heavily over-provisioned for what I committed for. But that's something to think about when we talk about the at-risk segment. This kind of gets into that construct of, do I have enough data for what I want to work with? And that's that insufficient data. I saw how much my current cluster is using. I'm going to commit to that. And then I actually perform some right-sizing activities, and maybe I possibly could have over-committed. So those are things where we talk about workload right-sizing. Key finding number 2 becomes that very critical element when I drive towards that. This kind of we also look at this from a utilization perspective. If I don't set requests, my bin packing is low. So think about this. If my bin packing shows that I'm 50% bin packed, I go, I could probably do less with 25% of my nodes. So I bring down those 25% of nodes. But because of my requests, I didn't ask for it, all of those are now consuming more resources. I actually don't have room. It's almost like at 50% bin packing, I am masking what's happening within my environment. I'm throwing more nodes at it in order to prevent the reliability thing I'm trying to prevent. So that's something we think about as well. If we over-provision our nodes, that can kind of hide some things that we're lacking within our environment. And I bring it down. I tear it down. I bring it down 25%. I don't want to go too crazy by doing 50%. Let's do 25%. But what happens to that overhead? I no longer have that wiggle room. So I think I'm doing, all of a sudden, I think I'm doing better in bin packing. But in reality, my workloads are at risk as a result of it. So from a Google Cloud perspective, for those of us maybe familiar with that optimization tab that's made available to you, metrics that are made available to you, recommendations. So from a Google Cloud perspective, even if I have VPA recommendation or I don't deploy VPA within my cluster, we're actually gathering some of those metrics for us behind the scenes as a metric. So that's something that you can leverage that we've kind of utilized in our dashboards to help you understand at a high level. Now, we understand from an optimization tab perspective, that is something that we see per cluster, which if I have 3 clusters and a handful of clusters, that's really easy to see. But we've also released dashboards to help you see at a higher level, at an organizational level. So there are tools that we applied and can we deploy that and be able to maximize how we look at those resources. We also have workshops and recommendations that are provided, workshops that Priceline went through. So these are things that we kind of go through to say, proactively, in a data-driven way, how is my environment? What is my current health? So this is something, if you're currently using Kubernetes Engine today, you can ask of your account team that we want to assess the health of our workloads and our clusters and go through that process. The other piece is, I talked about setting requests, I talked about all of these mechanisms to protect my workload. What are ways to potentially enforce that? So if we're not familiar with Autopilot, Autopilot automatically sets requests for us whether we like it or not. And we actually are forced to go back and reevaluate what my requests are because it will set its minimum. And either my workload is not going to work or I need to adjust that minimum because it's over-provisioned. So we kind of set forth that particular element. Another thing that we've just launched in preview is a cost and policy bundle for reliability. And being able to use this along with Policy Controller, OPA Gatekeeper, from an open source perspective, but also a bundle to help you enforce setting requests, setting labels on our workloads. I didn't speak any about this, but labels are very helpful for our workloads in order for us to categorize, but also setting pod disruption budgets, setting requests, enforcing that upon our workloads and within our pipeline. So there's a lot of things that from a Google Cloud perspective we can kind of help you with if you're taking advantage of it, and those are available. So that's at a high level for the report as well as GKE and kind of running through that. And with that, I will hand it over to Chris, and he'll cover what Priceline did for the workshop, as well as what they've taken further. So thanks, Chris.
All right, awesome. Thanks, Kent. Appreciate that. Hey, everybody. Hope everybody's having a great Next. All right, let's jump right into it. So Priceline is an online travel agency underneath of Booking Holdings Incorporated. We've been an industry leader for about 25 years. And over the last few years, we've embarked on a cloud journey. That cloud journey has been driven mainly by a cultural shift. And you've probably heard this story before. How do we shift our teams from thinking around the data center to thinking around cloud? So in supporting that, we had this massive shift within a few short years. What supported that was our infrastructure as code in terraforming, and you'll see the foundations inside the triangle here. Our FinOps approach, our modernization of our self-service approach for our development teams through an updated modern pipeline that allowed us to ship those workloads into Kubernetes. And we'll talk more about that. But prior to that, being able to ship your workload required us to have a 12-factor for those applications to make them resilient and really be able to be managed by Kubernetes. So here's a few topics we're going to dive into. We'll talk about requests, which Kent talked about, extremely important. The discounts we leveraged to try and make this efficient and cost-effective. The bin packing we used to reduce those idle costs. And the right sizing, the important right sizing of those applications to tailor them to what the application required and make it efficient in terms of what it's consuming inside of cloud. Lastly, I'll talk about traffic, egress traffic, and scale down. How do we scale these things down as well as scale them up and scale them down effectively? All right, so requests, right? Can't emphasize this enough. The reservation of resource for your container. How do I make sure my containers are effective in serving the applications that are running on them? Is by setting that minimum request. What is the minimum required amount of resource for that application to serve effectively to my end users? Those resources now are available for your container, and GKE will manage those containers as well as the pods they reside on. Those pods will move throughout GKE by process of its creating an efficient use of the consumption of those nodes. So those pods can be fluid, right? And the key point there is as those things move, you want to make sure that that request is there to guarantee, to Ken's point, that that minimum amount of resources available for your app to keep that app performant. So for Priceline, we needed to make sure that those CPU and MEM requests were gated in our pipelines to ensure that as teams are onboarding and migrating into Kubernetes, that they would have those gated requests already defined. Next thing I want to talk about is discounts. So standard use discount, or SUD, is a discount that you really get by proxy of consuming a resource for a period of a month. So it's kind of already there for you. You don't really need to do anything other than consume those resources, and that's for on-demand resources. Committed use discounts, these are things that need to be strategically invested within. Right? So for Priceline's approach, what we did was we teamed up across teams, communicating with our SRE teams, our program management teams, our application teams, about what's happening in our environment, what applications are being migrated, what applications are expected to grow, what do we see as different compute types that we want to consume, what's happening across regions. So all of these elements are key elements to consider when you're thinking about how to invest. Why is that? Well, I'll do a little segue about committed use discounts, standard versus flex. Standard committed use discounts are regional compute-based discounts. So if you invest on a particular compute type within a particular region, that's where that investment will reside. It cannot be ported to another region or a different compute type. So that's why you need to be specific about that. That team up about what's happening in the environment would then generate a report for us to say, here's what we think is happening over the next 6 to 12 and 36 months, and how do we plan on investing to support that? Our investment strategy has been target 80% coverage. That'll give us flexibility for eventualities in that period of time, because this is a commitment in a committed use discount for 1 or 3 years. We also staggered our investments. So as we consume, expirations happen over the course of the year, which also provides additional flexibility. So when you consume in thousands of cores, when you have a significant shift, you can pivot with that. There's discounts. All right, next slide. All right, let's talk about bin packing, right? So cluster autoscaler is a fantastic feature in Kubernetes, right? Which allows, as Ken said, the nodes to expand with consumption or scale down. So scaling up and scaling down. This essentially packs those pods in based on what the requests are for your containers. So the key here for us was to get a communication across our organization to trust in the process in cluster autoscaler, based on the fact that your apps have been 12-factored, so they will be resilient, and based on the fact that you've set requests for a minimum performance on your applications. So trust in the process. We engaged initially in the balanced profile, which is essentially the default profile, and it's a safer profile. It's not as aggressive as the optimized utilization profile. The optimized utilization profile was what we later followed on with, and as that's more aggressive, it's going to give you a much more larger reduction in your idle costs, but it'll also create this situation where it takes a little longer to spin up your pods. Right? So because it's so aggressively downsized, there's no extra idle resource for you to spin up quickly. So how do we deal with that? Well, we use what was called pause pods to set additional reservations to allow us to spin those things up quicker. Right? So all of those efforts, really, we've seen up to 60% reduction in those idle costs, which was amazing for us. All right, so right sizing. There's a couple slides on this one, and I broke it up into 2 sections because I think the organizational piece of this is really important. How should our teams tune what is required safely and efficiently? Communication is the most valuable tool you're going to have in your tool belt here. So you want to identify and agree on what the high-value targets are. So high yield, low effort is the key. You also want to set up guidelines and guardrails in documentation, reviews that's easily consumed and easily actionable. Additionally, what we also did was we leveraged what we call our architecture guild, where teams participate in open communications about how to consider what their app consumes, how to consider what happens in zones or regions. This open conversation allowed teams to air out their concerns, whether they could consume what guardrails or guidelines were there, and allowed us to pivot on making those more efficient as well. Lastly, program managed, to be able to have TPMs across teams participate with the team in moving that ball from less efficient to more efficient in right-sizing the application and testing through that SDLC. All right, so execution of that right-sizing. Here's some of the actual tools we leveraged. The first piece was a dedicated performance operations staff. So our embedded DevOps team was created for focus on things like performance and consumption. So how performant is my application? And how do I consider how efficient my application is? So those teams help focus with our SRE teams to get those applications fast-tracked into a right-sizing process. Additionally, in our emission controller, we use mutating webhooks to gate what can be deployed in our non-production environments. So as an application team may have sets of requests that they want to run at a certain level and move that through the SDLC, it may not be necessary, and the webhook gates that, so that we're not deploying in non-production resources that aren't being consumed. Additionally, workload-aware visualization. How do we show development teams what their app is consuming? In Priceline, we are an active multi-region deployment. So I need to know what my aggregate of consumption is at any point in time and over a course of time so that I have a reliable set of metrics to base my decisions upon. Okay, into traffic. So as a multi-regional deployment for our runtime, we also have multi-zonal, right? So lots of layers of resiliency and redundancy there, which is fantastic. But it also generates a concern around egress traffic. It's very easy to consider regional egress traffic. It's the first thing you think about. It's very expensive to have traffic egress across regions. But additionally, interzone traffic is a very significant expense and needs to be examined. 58% was the amount that we were able to hit in reducing our interzone egress costs, which is tremendous. We leveraged Istio, we have as our service mesh, and we leveraged locality load balancing to keep those traffic patterns within zones. Topology awareness was another component we leveraged on top of that. So topology spread constraints, how do my pods deploy inside of my zones? Set spread amounts so that you have those across the zones that you have deployed. Lastly, reporting. How do I see things are happening with the traffic from a traffic perspective? From a billing perspective, you can go to the billing console, look at SKUs, filter based on that, and see what the interzone egress costs are, what may be spiking across what projects, or what particular namespaces. Lastly, you can investigate into that through things like Network Intelligence Center and its topology viewer. It's another fantastic tool. All right, so scaling. A couple slides left before I'll be turning it over to Thomas to talk about some of the Kubecost and visualize some of these things. But scaling up, as Kent mentioned, is very key to a lot of organizations, especially those that are retail and go through things like Cyber Monday, right? So how do I scale up? HPA is a fantastic solution for that. It also scales back down for you. So how do we make sure that we're scaling up and down safely? What metrics do we target? Is an effort per application team to look at their apps and figure out how to target which particular metrics. So target your high-value applications. Again, you want to look for high yield, low effort to get you the quickest return on your investment of effort, right? Additionally, partnershiping with teams. So pulling in your site reliability engineers, your infrastructure teams, and program management to think about how we're going to move this from one level of static to an HPA. Lastly, as I mentioned, multiple regional resiliency, we had to think about, okay, so if we have regional maintenance, how do we warm up a site that's running an HPA? Because HPA will balance those traffic loads so that the less hot site, I'll call it that way, the warm site, has less traffic than the hot site. How do we warm that up or heat it up so that it's ready to take traffic? So we had to approach this with the strategy of pre-warming those pods, launching them in, and that's where our SRE team, architecture team, were able to create a loosely coupled architecture and win that Google Cloud DevOps Award. All right, So we talked a lot about scaling there with HPA. Scaling down is the big trick here, though, for multiple zones. Scaling down requires effort to optimize. Remember that cluster autoscaler does scale your nodes up and down, but it does not have topology spread constraint when it scales down. So we use things like Kubernetes SIGs descheduler, which reviews how the spread is existing, and it evicts pods, and then the cluster autoscaler will then redeploy them according to the topology spread constraints. So essentially, it's evicting what's overloaded and allows the autoscaler to bring it back up to parity. All right. Lastly, to sum this all up, folks, community-based, right? I mentioned a number of times, teaming up, having multiple teams talking across each other. Communications is the most valuable tool. So that's a key point. High value, low effort, another key consideration. And easily consumed, actionable guidance goes right along with communication as a key. All right, with that, I'll turn it over to Thomas. Thanks, everybody.
Good afternoon, everyone. Can you hear me all right? There we go. Right on. So my name is Thomas Evans. I'm the Director of Engineering for Kubecost. And Chris and Kent just gave you a very technical deep dive into something that our product's going to make really easy for you really, really quickly. But before I get into that, let's talk about how Kubecost came to be. Very simply, we are a cost optimization tool that is solely focused on optimizing your Kubernetes spend. So we're going to give you great visibility. We're going to give you great action items that you can use to go exercise your FinOps muscle against your current Kubernetes offering. So our product was built by two former Googlers, Webb Brown and a Jay Trippathing, who came out of here, oh gosh, 4 or 5 years ago now. And they quickly realized on the old Borg project, Kubernetes, or what was going to be Kubernetes, was a very complex problem, right? Really, really good at giving you flexibility in your workloads, giving you a whole lot of configurability and a whole lot of opportunity. It was really, really bad at letting you see any of the magic under the hood, right? Particularly when it came to cost. It was really good at throwing things in the pool, racking up your bill every single month, and you having no idea where your money went, right? Really cool. So that's where Kubecost comes into play. We're going to give you a really clear solution on how to identify your costs. We're going to allocate them back, we'll do chargebacks, we'll do all sorts of actionable insights that let you really go in and exercise your muscles against these golden signals that Kent and Chris just talked about. So let's talk about just 3, right? So I think we offer 12 to 15 in the product depending on your configuration. But to start off, let's talk about the resource requests, right? The obvious low-hanging fruit in the room. Kubecost will provide a page that allows you to dive in and see which workloads either do not have any sort of resource requests set to them, or which ones are under or over provisioned, right? And so we've got a couple of different algorithms, and you've got some options on how you actually want to calculate those. But we're going to provide recommendations that say, hey, you're 40% over provisioned here. You really need to go adjust this to really help your bin packing and your other side effects from this. Looking at leverage demand-based downscaling. Again, Kubecost provides a couple of items here that lets you go in and automatically downscale your workloads as need be based upon different components throughout it. And then finally, discount coverage. Sad to say, Kubecost AI can't quite call Google and negotiate your bill down. We're working on it, but for now, we'll stick with reserved instance sizing and spot instances as well. And we're going to go in and be able to identify some of those workloads that are ready for you and provide recommendations based on that. So, the fun part about today, for anybody who's familiar with our product, it has to be installed in your Kubernetes cluster in your own cloud. However, that is no longer the case. Kubecost Cloud is now available. It is in general availability, and it's a simple agent install. And we're going to give you these golden signals in a little under 5 minutes. So, all of that said, we'd love to bring Kent and Chris back up. We'll talk through a couple other components here.
So I kicked things off with the report as far as the first couple slides. So this is an opportunity, if you haven't had a chance to download the report, these slides will be available tomorrow as well in PDF form. But the QR code, if you want to download the report and see in detail what I was able, and the team, everyone was able to summarize, and then work through kind of that process to kind of understand what I talked through, but also what else is there available for the team to kind of realize within your organization. And as a part of that are other sessions that are available related to cost. Chris gets to tell us, not today was about GKE, he has other sessions that talk about overall GCP. So if you're on GCP, the opportunity how you can look at it from a cost perspective for all of your GCP environment, but also some other areas around what's new with Kubernetes. And in the showcase booth, or demo booth, there's also some pieces that I believe Broadcom also goes through from a optimization perspective. So other sessions for you to keep in mind as well beyond the report. And then I believe Kubecost has something as well.
Yeah, so two things. So please come see us. We're at booth 1650 downstairs. We'd love to talk to you and walk you through some of the finer details of Kubecost Cloud. But today we're also partnered with ThoughtWorks. So today at 6 o'clock over in ThoughtWorks' headquarters just across the street. We are going to have a happy hour with them. Would love to see you over there. Would love to talk through some of these details that we provide.